Let's do an example in this video. So we are given this function from R2 into R2, that is x squared y squared divided by x to the power 4 plus 7 y to the power 4 whenever xy is not 0, okay, because of the denominator. And when we are at 0, 0, then f of 0, 0 is defined as 0. That's this line over here. And the question is this function continuous at 0, 0? Is it differentiable? Okay, so let's get to work. So the first thing we are going to check is continuity, just to be sure. So continuity, what we need to check, we need to check that the limit as xy tends to 0, 0 of this little monster here, x squared y squared, right? The values of f of x outside of 0, 0, we need to check that it is 0. So this is the big question, because 0 is the value of f, the way it's defined at 0, 0. So let's see what happens. Yeah, sorry, this is a function that goes from R2 into R. I wrote that wrong. Now, that's the reason why I'm not writing bars here, because it doesn't matter. Now, to check the continuity, here there are two ways to go. It depends if you believe it's continuous or not. I believe it's not. So when you think it's not continuous, then you need to check different paths to see if it breaks the continuity. So here, because we have, you see what happens, we have power of 2 for both x and y in the numerator and powers of 4 in the denominator. When that happens, you may have noticed the powers add up. So you have a net power of 4 between x's and y's in the numerator. And then it's a 4 also in the denominator. So that's no good. Here, what you would like to take is what happens if we take the path x equal y equal t. Okay, so if we are looking at the plane x and y, we are approaching 0 following this line. Okay, so let's see what happens. I'm choosing both equal, you'll see why. Because that way we can collect all the powers into one. So let's take the limit as t tends to 0 of f of t, which is the limit as t tends to 0 of t squared divided by t to the power 4 plus 7t to the power 4. And this is the limit as t tends to 0 of t to the power 4, divided by 8t to the power 4. But you see, the t to the power 4 disappears, and this limit is 1 over 8, which is definitely not 0, as we would need. So we can say that the function is not continuous. And if it's not continuous, remember, if a function is differentiable, then it's continuous. So if it's not continuous, then it's not differentiable. So not differentiable at 0, 0. Away from 0, 0 is fine. Okay, that's the only point where there can be conflict, because there is the denominator becomes singular. You would be dividing by 0. Okay, you can graph this function and you will see that when you approach from this line, then there is a problem. So I just went ahead and plotted the function. Here we have it. And here we can see that actually the limits are very different depending on the direction we take to approach 0, 0. Okay, you see here clearly the direction when x and y are equal, right, is that high line that it looks like 1 over 8. at limit, okay? But if we take the axis when x or y are 0, then it looks like the function is going to be 0, of course. So you can see that depending on the path we choose, we will get different values for the limit.